Hi, I am Navarun Kaur, and I, with my teammate Jaideep, have worked on this project of financial portfolio optimization using deep reinforcement learning for our deep reinforcement learning class. In this video, I'm going to explain how our code works and go through it. So, initially, we're using this Colab repository for holding our code. We have just installed and imported a few libraries which are needed to run our code. Next, we load our dataset. For this project, we are using real-world data from S&P 500 index. It's historical data. So we have loaded this dataset and we have printing the first few lines as an example. Next, we move on to set up our environment. It's a custom gem environment and it is initialized with several attributes such as the current step, balance, share cell, and so on. As we can see, it has an action space and an observation space. We define the other methods, which are pretty standard methods like reset and how steps work. Inside the step method, we can see that how the agent performs if there's a buy signal or if there's a sell signal. And so this is basically our custom environment that our agent is going to interact with. Next, we execute some deep reinforcement learning techniques like proximal policy optimization, advantage actor critic, deep deterministic policy gradient, and soft actor critic on this custom environment. We execute it for 50,000 time steps and get some results, which I'm going to show you here, right here. Yeah. So after executing for 50,000 time steps, we have the following results, where we can see that deep deterministic policy gradient is not performing well. It's slowly losing portfolio value over time, whereas the other three agents are performing more or less similarly. Next, we move on. We move on to a new environment where it's pretty much the same as the old environment, but we have introduced a new volatility factor in the environment. So volatility is the rolling standard deviation of return, and it determines how volatile a stock is. So it's kind of a risk factor, and we see how our agents are going to perform in this environment now that volatility has been introduced, and it is a factor which the agents have to consider while making a decision. So similarly, we train our agents for 50,000 time steps with this volatility factor introduced, and we can see how these agents perform. So yeah, soft actor critic and advantage actor critic go down in performance, whereas deep deterministic policy gradient and proximal policy optimization perform uh, more or less in a stable manner. Next, we move on to a meta agent for strategy selection. So this works in a few steps. So we train a few sub agents on two different policies, such as momentum trading and value trading. So value trading is a conservative approach where we buy a stock and expect its value to rise over time, over a long period of time, whereas momentum trading operates under the assumption that a stock which is going down or going up in value over the last few days is expected to continue in the same direction. So what happens is, here we train two sub-agents on these two different policies, which are value trading and momentum trading. And we then the job of the meta agent is to select the agent out of the sub-agents that learned value trading and momentum trading, and to select the better agent so that our portfolio is more optimized. Now, this happens right here in the simulation of trading. So what happens is, every 50 time steps, it checks whether our portfolio is losing money. If it is losing money, then it considers switching from either value trading to momentum trading or the other way, depending on which policy is being used that is losing money. So we have trained this on around 250 time steps, and this is the performance that we got. In this example, it actually made a profit of $70 because we started out with $10,000 and we ended with $10,070. And but this is not the example that we have used in the project report, because the performance of this can be a bit unpredictable. We have also trained a few random agents, tabular Q learning agent, tabular SASA agent, and deep Q network agent on a custom gym environment. And we can see how these agents perform in a custom environment with the help of this graph. So yes, that will be all for this video. Thank you.